Welcome to another video by Only Keypads. Don't forget to visit the website onlykeypads.info for more information on the keypad builds. Only Keypads is for the hobbyists and nothing more. The following video is for hobby purposes only and not intended for commercial or consumer printed circuit boards. The video demonstrates a low-cost solder pot for the hobbyists in need of producing custom PCBs. I wanted to make a video on solder pots that's geared more towards the hobbyist who may have a few circuit boards that they want to solder over the weekend or in the evening or something. And I'm kind of in that same boat, and I struggled with buying an expensive solder pot for $200 or maybe even sometimes more. So my first one I came up with was this one here, and basically all it is it's an old stovetop coil burner, and I put a thermostatic control on it. Okay, that has a thermocouple like this, and it runs off a 240 volt, so I didn't really care for that too much, but it worked. I put a high-low switch on here. Either it heats up half the burner or the full burner. And for my pot, I used a cast iron skillet, okay, that you can find in basically any sporting goods store, Walmart, anything like that. They're fairly cheap when you go in the sporting goods sections. And for the solder, I use a 6337 blend solder, which I usually get off of eBay, fairly cheap. Usually the solder goes for about $20 to $30 a bar, but it goes a long way. Okay, and like I was stating earlier, this one worked, but the problem was I could never really control the temperature too well. Even with this thermocouple here, I would try to put in different positions around the pot and things of that nature, and either it would overheat or underheat, and I would end up warping even some boards. That's how hot it got. So I kind of figured I need to go back to the drawing board, and what I really came up with was a very simple solution to this problem. Is I went and I purchased one of these burners that you see here. Okay, if I can get it in focus here. Alright, there we go. Alright, I picked this one up again on eBay. I guess I'm a big eBay shopper. This one is a 1100 watt, 120 volt burner. Okay, and it has a temperature control knob on it here. And I use the same skillet, same solder, and this one seemed to work really well. It seemed to maintain my temperature that I was looking for, and I'm going to get this plugged in and get it heated up because I'm going to solder some boards today. Okay, and I'll run you through some demonstrations on how this works. Alright, so I'll be back in a couple of minutes once I get everything set up here, and show you my simple solution to a cheap solder pot. Okay, I'm back. I got my homemade solder pot heated up. Typically I try to heat it up somewhere between about 338 to 460 degrees F, somewhere in that mid-range in there somewhere. I have an infrared gun here. I'll try to come up with it here on top, but it's tough to get a good read with this sometimes. This is saying about, I don't know, bounces around. It's probably a little over 300, 308, 310, 320. Okay. What I usually do is, and I learned this from somebody online, is take a piece of newspaper and just put some newspaper, just brush it here, and if the newspaper turns brown, okay, your solder pot is probably hot enough. So typically that's what I do. Alright, and that's kind of turning brown on this one side there, so I figure this is probably hot enough to solder. Typically I'll set the control knob somewhere between 4 and 5 on this burner that I have here, and that seems to regulate pretty good. It goes on and off, it regulates the temperature, doesn't overheat, doesn't underheat. It takes about, I don't know, 10, no more than 15 minutes to heat up. I don't have a lot of solder in it. There may be about a 3/8 of an inch depth of solder in there. So that's about it. That's why it probably doesn't take too long to heat up. Now on the boards, this is one of the boards here that I'm going to be soldering. And there's a pin connector here, okay? And I don't want to put that header pin in there at this point. So what I use is, I use this high temperature tape. You see that yellow amber colored tape on here? And that works really well. It comes in a small roll, you get it in different widths. Okay. Again, I got this on eBay. And this way I can put any type of pin header in here that I desire later. That's the reason I do that. Okay. And all I do is I take the flux. Okay, I'm using this flux here. Okay, it looks like it says 186 no clean flux, mildly activated rosin, liquid flux. That seems to work well for me. Okay, and I just take a little acid brush, dip it in the flux, and brush it on the board. Okay, I let it sit for a few minutes, and what I'll do next is I'll take a heat gun and I'll warm the board up. I don't know, somebody mentioned this on some YouTube videos I watched, and you should heat your board up a little bit. Alright, it'll help adhere the flux to the board better and preheat the board somewhat. Usually, I think they were saying something like 150 degrees F. I just put it under the heat gun for a little bit here. I'm not going to get that technical and measure it. Alright, so I'll just heat this up some, like that. Okay, make sure the solder is adhered to the board and still, like, you know, liquefied. Okay, alright, let's heat that up some. Okay, and then what I'll do is I'll take a piece of parchment paper or freezer paper. This is freezer paper, and I would just wipe this slag off with freezer paper for now. I didn't have any parchment paper. Okay, you see how nice and shiny that's getting now? Okay, that just cleans all that flux off of there. Alright, then I'll take the board. I put a little bolt through the board and a little nut so I can hold it. And I'll put it in here for about 5 seconds, and I'll just count it. And I'll just hold it like that and leave it cool. Alright, usually I like blow a little air on it, but I got the microphone on now, so I don't want to make any disturbances over that. Okay, then I'll flip this upside down real quick. You can feel the heat coming through that bolt. You may want to wear a pair of gloves. Okay, you can see how nice that got. Now look at even these transistors that are on here. Look at those transistors. There's no bridging. If I can get them in view over here. I always go the wrong way with the camera. Okay, but you can see the transistors right there at the bottom of the screen. Look at that, no bridging, no anything. Even in those ICs, it really does a nice job. Okay, now I got a bigger board here that I'm going to do too. Alright, this is going to be a bigger board. So again, I'll just take my heat gun and I'll just warm it up a little bit. Make sure that solder is adhered and liquefied. Let's heat it up some. Really works well. I mean, for the cost of a skillet and a burner, Probably lucky if you have $20–30 wrapped up in this, not even that. I found it to really work well. And it serves my needs. I'm not no mass production facility where I gotta mass produce these. This is just a hobby. Okay. And again, I'll take my freezer paper and I'll just clean this off here. Get rid of that slag. And you gotta clean it big enough, of course, for your board width. Okay. If you don't have wide boards, you don't have to clean it as wide. Okay, that looks pretty good right there. And I'll take this board and I'll just set that right down in here in about 5 seconds. Okay, so far it looks good. I just hold a little bit, let that solder freeze a little, and then I'll give it a quick flip over. Okay, and that bolt gets hot, so I should probably have a pair of gloves on myself. Okay, but you can see how nice that is. Look at them ICs, no bridging, nothing. Beautiful. Beautiful. Okay. Alright, I might have got a little bridge right here, but that's nothing. That's on that pin header. But I'll take care of that with a soldering gun. Okay, but all in all, it really worked well, especially on those ICs, because they are tough sometimes. They want a bridge. Okay, so I'll take care of that little bit here, and that'll be it. Okay, and these bolts, you just go to a hardware store, you have to fit them. I think this is a metric bolt I use here. I don't know if there was such a thing as a 540 or something like that to fit the holes in the board. These boards, I actually got them made on Easy EDA. Okay, so these are all custom boards. Okay, this is for the only keypads. This is a 2-wire encoder board for the only keypads. And this is the 4017 chaser encoder board for the only keypads. I'm going to do some keypad 40s, so I'll be back in a little bit and we'll do a few of them. Okay, be back. Okay, I'm back. I got some of the keypad 40 boards already prepped to go. Okay, that's these guys here. Alright, these are the 40 keypad. Let's see them here. Alright, again, the pin header, I put the high temperature tape on it. You can see the amber tape on it. And the flux, there's no need to overflux. I just take the acid brush and I just put a real light film, the flux, on the board. Okay, there's no need, I didn't find a need to really like dip them, or I've seen some videos where they're dipped into like a little solder bath kind of thing, but I don't do that. I just put a film on them. And another thing I just want to bring up is like on these resistors here, or any component really, before you dip them, make sure that all of these tails on these components are bent over. I ran into a couple instances where when I was putting the solder on, the acid brush would snag one of those tails and pull it straight. And after I had them dipped, I realized that that tail came out of the hole on the board, and then I had to go back and try to re-solder it back in with a soldering iron, and it was not fun sometimes. So a quick visual inspection of the board before you dip it is probably beneficial. Okay, the solder pot's been heated up now for, oh geez, probably well over an hour, hour and a half. And it's been holding good temperature. Okay, I'm going to just put the paper back in again. And we'll see what we got here. Okay. And I backed it down just a hair. I was on 5. I put it down on 4. Okay, and you can see the paper is getting like brown, so I'm figuring that's hot enough. I don't want to overheat it, and that's hot enough to solder my boards, so we're going to find out. Okay, the gun, I don't know, we can take a quick look at that real quick too, but alright, see, we're up there pretty good. We're about 380 now. We're hitting around 380. That's why I backed it down to about 4. But it works good for my intents and purposes. Like I said, I'm not here as a commercialized business. Okay, on these keypads, I have a frame, and I put this frame over these keys because I want to hold these keys in certain position, because there is a little bit of play in these keys when they go through the board until they're soldered. So this holds the keys into their exact position, so when it's done I can put the overlays right over them, or the frames. Okay. Alright, so what I'm going to do is I'm going to just take my heat gun again, and we're just going to heat one up. Let me get this gun on here. Okay, I'm going to heat this up some. Like I said, it helps adhere that flux to the board and liquefies it a little bit. Yeah, I keep it on there, I don't know, 30 seconds or so, something like that. I don't get too particular with it. That's probably good there. Okay. Alright, and what I'll do is I'll put the frame over it. Okay, and get it ready to go here. Take my paper again, and I'll clear some of this slag off of here. Now these aren't very large boards, so I don't have to clear the whole pot, just the area where I want to dip the board. Okay, that's probably good there. A little bit there yet. Okay, and like I said, about 5 seconds. Okay, so let's see what we get. Okay, let me take it off here, let it cool. You can blow some air on it if you want. Helps freeze that solder quicker. Just flip it over real quick. Okay, and you can see how beautiful that got. No bridging. All of those switches, there's no bridging between them. Nothing. Okay, and then I'll just take that high temp tape off of there after everything's done. I can grab the end of it here. Okay, and those holes are all through holes yet. Okay, it's probably hard to see on the video, but they are. Okay, you can see they're through holes yet. Okay, so I'll just put my pin headers or screw terminal connectors, whatever I feel, or just solder a ribbon cable on there later. Okay, and then I'll just take this frame off of here and get ready for the next one. And that's pretty much it. I got about another 10 or 12 to do, but I just wanted to demonstrate this one to show how it's done. Okay. All right, so I found this to really work well for me, and for the average hobbyist, you don't want to spend a couple $100 on a solder pot. You can build this for $20–30, and I hope this helped, and I hope everybody that needs one can build one, and they can do their soldering in their basement or garage. And like I said, these boards, these are the I use them on the Oni keypads, and I designed and had these boards made on easy EDA, and no warping, no anything. And like I said earlier, I had my solder pot too hot on that older version pot that I showed earlier, and some of these boards actually warped on me. So this one seems to work well. I have not had one board warp on me yet. Okay, because I'm not saying these are the highest quality boards. Like I said, these boards are just made for hobbyists. They're not made for consumer or commercial products. Okay, it's for a hobbyist that wants to prototype some projects, and these really work well. Okay, so I hope this was help. All right, thank you for watching. Just a couple of things I wanted to add here quick. I just wanted to show on the flux. Like I said earlier, there's no need to really overflux. I just dab the acid brush in the flux a little bit on the front and just lightly go over the board like such, and just put a thin coating on it. No need to overflux. because you're only wasting the flux, and it's not cheap today to buy that flux. Okay, I think a small bottle was like $8 or $9 that I have here. Alright, and that's pretty much it with this, and that's it. And real thin film, just like that. And after it's all soldered, I usually use a simple green to clean the board, and you may want to wash it with a little bit of 90% rubbing alcohol. I found that to work. And I don't clear coat the boards, okay, because they're not, these boards aren't meant for like commercial or consumer products. These are just for a hobbyist who wants to build a project or prototype a project. So, you know, if somebody wants to clear coat them after, you know, waterproof them or whatever, or corrosion proof them, that's up to the individual. But like I said, these boards aren't meant for that type of product. So, all right, I just wanted to show that real quick because there's no sense to overflux. All right, okay, thanks. I just wanted to wrap up just to show all the boards I did. There's 12 boards here, and I just wanted to show that the process is repeatable. It's like anything else. You can build a project, the first one will work and the next one won't. And so this is fairly repeatable. I did have one board that was had some cold solder joints on it. I just went back, refluxed it, and redipped it, and it's fine. And other than that, it came out pretty nice. You can see here. Alright, these are all the front of the boards. Okay. And this is the bigger board I did earlier. That came out really nice. So now the next step is to take them, test them. Well, clean them up first and then test them. And get ready for the next batch. So I just wanted to show that it is repeatable. So my under $30 solder pot seem to have done the job. Alright, I want to thank you for watching, and I hope this benefits some hobbyists out there that don't want to put out a few $100 or $200 for a solder pot. Alright, thanks again.